Hello, everybody. Welcome to another Smart Building Series webinar. And today we are discussing Project Haystack, 10 years of bringing data semantics to the built environment. So I'm very happy to welcome John Petze and Marc Petock from Project Haystack. We're going to be having a discussion with them all about Project Haystack, where it's come from, where we are now, and what's in its future. And also promoting the Haystack Connect event, which is coming up soon as well. So we'll be going through all of that soon. We are all very interested to make this an interactive session. So if you guys do have questions, we'd certainly welcome them. Please put them ideally in the Q&A box there, which you should see on the bottom sort of right hand of your window. Some people use the chat, which is fine if you want to do that, but Q&A I think is preferable. What else can I say? Oh yes, that we are recording, of course. So we'll be putting this up on YouTube, our YouTube channel later. So if you search for Smart Building Series on YouTube, you'll be able to find this content probably up tomorrow. And of course, all of the other webinars that we've done. We do one at least every month. So stay tuned as well. You can follow us on social media, Twitter, LinkedIn. You'll find out where to find us. So yeah, that's me. John, Marc, hi guys.
Hey, good to talk to you again. It's been a while.
It has.
Welcome
back.
Yeah, thanks.
Thanks, James. Delighted to be back with you.
Yeah, and I'd like to reiterate that we appreciate the role you're playing in helping get information out to the industry. We've had the opportunity to speak with you a number of times, and it's been a fairly good while since the last time we talked. I think it might be coming up on 2 years, although everything's a blur with last year.
Yeah.
So we really appreciate the opportunity to help enlighten people about this topic.
It's important that we keep up to date with these projects and what's happening. And so yeah, I think it'd be great. I mean, we're going to go through some slides, I guess, first, and then as I said, like anyone who wants to ask some questions or even make some comments, then please put them in the Q&A, and where is relevant, I'll be able to put those into the conversation.
Yeah, we definitely want, hopefully we'll get questions that we can respond to. But yeah, one of the things we always like to do is, I know that we end up talking with people who do know what Project Haystack's about or are dealing with these topics, but we find that a brief, what it is, why it's important is always helpful, right? And so if you give me a few minutes for that, kind of frame the rest of our conversation, right? We've been around for 10 years, great. Why and what are we doing? So let's talk about that briefly. So, the whole goal of Project Haystack was to address this challenge of how can we make the data that comes out of all these smart and connected systems more easy to work with. And, that's really the mission we started on. And in fact, I think one of the interesting things is that society as a whole is becoming more and more aware of the importance of data, and they're becoming more and more aware of the challenges of working with data. It often is nowhere near as easy as you might assume, just because you have a device that may have an open protocol and can provide data. And the challenge really comes from this. The data that's produced by the huge volume of devices and equipment that populate our built environment doesn't have good descriptive information to describe what the data means. So within a single silo system, the people who built it or installed it know what the data means, but you want to take that data across into other applications, use it for different purposes, and you're left with a challenge because names can't do the job. I think this is a great way to try to help bring the concept out. Marc Petock, that's your name, right? That doesn't tell me anything about you and all of your other attributes, where you live, what your age is, what your profession is, all of those things, right? we would never try to think to build all of your essential information into your name, right? And so this is, I think, one of the first things people learn when they address this challenge is, oh, there may be names, they may even be standard names, but they don't tell us what that means, right? And what happens, you end up with a labor-intensive manual process to add those attributes. Well, I could use the word attributes, but in the world of software, it's semantic definitions, okay? Semantics, metadata, right? But you have to do that before you can do anything with the data, right? Do analysis, analytics, even present it, put it on graphics, or use it for control decisions, right? And so this barrier adds costs. It slows down the process of generating value from the data. And it's a fundamental challenge across the technologies, the systems and devices in the built environment. And so that's what we set out to help solve, develop a standardized approach to what's considered semantic modeling of equipment systems. And as we noted, yeah, we've been at it for 10 years. One of the important things is that, in addition to providing this standardized methodology, right, this has been developed by a global open source community over the last 10 years. And, I think that's worth highlighting. We hear the terms open source thrown around a lot. There's open source that was developed by, there's companies who develop stuff and make it available as open source, right? Or, small groups who solve a problem and make it available as open source. The difference here is that the diversity of systems, diversity of applications, it has taken a global village of people to address this problem, right? And so the standard and the libraries and the tag libraries and ontologies that have been developed, that came from collaboration of hundreds of people around the world. There's thousands of people who are part of the organization, but hundreds of people actively working to solve this problem. Now, on the licensing side, it's all open source license, so you can download everything the community has developed in the last 10 years. In fact, you don't even have to register to download, right? So that's a key part of it. The other thing is, how do we solve it? It's the concept of tags, right? That draw from, little manila yellow paper tags. If I was going to go in and do an inventory or try to figure out what do I have in my garage or attic, I might add tags to the thing and say, here's what's this in this box, et cetera. And that's really the fundamental basic concept here is we're going to add tags to describe what the data is, what the systems are, and their relationships. And we're going to do it in a logical way that's both human readable and machine readable. And that's been really important, right? One of our philosophical commitments early on was this has to be understandable by the people who are installing these systems. And you know what? Adding some tags to describe what something is when you're setting up a system, that's very doable, right? That's very achievable. So, but then we talk about, why, right? And I've hinted at the why, but maybe, let's talk a little bit about the why. So Marc, I'm gonna bring you in here. Talk about the benefits and value of why this is important to people.
It's interesting, being involved with this for 10 years is we have seen the benefits and the value just continue to expand. So for example, let's kind of look at this from several places. So those who utilize Haystack methodology, so owners and operators, again, you can see that John has depicted on the screen, faster time, faster outcomes, data uniformity, tagging in accordance with agreed industry definitions. If you're in the facility side, it's consistent data, cost-effective analytics. If you're an SI, MSI contractor, the last thing you want to do is spend more and more and more time on a project or a job. So taking advantage and utilizing Haystack methodology allows a system integrator to reduce their time on a job. And then especially now too, let's look at the equipment that goes into our buildings or delivers an IoT deployment solution. Again, people want to get that data, use that data, and deliver some type of value. But, you know, for me, one of the interesting things, and I think it's one of these aha moments that we all in this industry, we kind of get. For me, about a year and a half ago, where Haystack and data kind of collided, I think is the best way to look at this, is it's not just about exchange and integration. Those are no longer enough in today's business and built in IoT climate. It's really about interoperability and the true, open, cost-effective interoperability that is required in order to really maximize that value that data can bring. So and I'll sum this up just real quick. If we look at Haystack's role in interoperability, look at Haystack as providing a foundation to support open interoperability that enables one system to exchange data without manual effort being required to enable the receiving system to interpret that data. Then look at it from a structural interoperability perspective, that Haystack provides by defining the data structure of the information being passed through the system. It enables that structure interoperability. And then finally, Haystack provides this open semantic interoperability whereby multiple and disparate systems can exchange, interpret data, and use that data to the fullest extent. So ultimately, again, what I'm trying to get to is there's the methodology side of this. There's always a technology side, but the business side of what we're doing, I think, really resonates in today's environment.
Yeah, thanks, Mark. You know, I want to pick up on that word data interoperability because, you know, having been in the automation industry for a number of years, you know, a lot of people assume that we get interoperability from the open or standard protocols out there. And you get a level of interoperability. I can connect to that BACnet or Modbus or, you know, device, MQTT device, whatever. I can connect and I can get bits across the wire. But when we're talking about data interoperability, we're talking about, can we easily use that data? Do we know what it means? And can we use it in other applications that may have had nothing to do with the original piece of equipment, you know, that wasn't within the, you know, the design intent of the manufacturer of the device? And in some ways it's subtle, but it's actually the most important thing is we want to be able to easily use our data, right? We paid for the devices, we have the data, and, you know, data leads to better understanding, and, you know, that's all, you know, dependent on being able to actually make the data interoperable with minimal effort, right? Because if we have to invest too much effort, then we're not going to get to our end goals. So, you know, we try to sum it up, right? These benefits, right? And, you know, we say enabling a future where a push of a button can turn device data into true intelligence. And, you know, I like to make analogies that may help people who are new to the subject. And one of them that I like is, you know, plug and play on, you know, the IT equipment I have in my office, right? You know, I've been around long enough to remember when hooking up a printer was a major undertaking. You had to get the floppy disk from the manufacturer, and it was only compatible with this version of operating system, and this, that, and the other thing. And, you know, hooking up a new printer, I mean, this was an engineer's effort in most cases, right? Now we live in a world of plug and play, and while there might be a glitch, you know, here and there, you know, anybody can go into a store and they can buy a printer and they follow the 3-4 steps and they're printing, right? Why is that possible, right? It's because there was a defined methodology approach around not only the communication over, you know, IP, but the information and that would be published by devices and the way they would interact with each other. And what did that do for us, right? It made it so, you know, the options we have for printers, the cost of printers, you know, it just exploded for us and made, you know, business better. And that's what we're talking about here. When we get to true interoperability of data, you can push a button and get to your end result. A good example of this is, if you have Haystack tag data, you can have a software application that simply interprets the meaning of the tags and automatically draws or assembles graphics, the pictures of the air handlers, chillers, VAV boxes, production equipment, whatever it is. That's a huge advantage, because the amount of effort that goes in, like Marc was saying, system integrators, they don't want to waste effort doing things that could have been automated, right? That's really not a value add to anybody. Another example is, you can write a control sequence and say, this control sequence applies to equipment with these tags, and the control sequence finds the equipment it's supposed to control. These things are happening today because of Project Haystack and manufacturers of hardware products and software that are adopting the technology to dramatically simplify the effort involved in connecting and getting value out of equipment, systems, and buildings. So that's hopefully, Jim, a good recap and maybe an introductory point for people who may be new to this. And
yep, absolutely. Yeah, and actually, it's probably a good time for a question here, because this is somebody who I guess is new to Haystack. He says, I see the benefit of this, but have never implemented it in our BAS IoT projects. And what does it take then to go from 0 to 100% Haystack? And in their case, he's saying that a typical project would be around 2,000 to 10,000 points.
Yeah. Okay. So
cost
what is it?
Learning curve.
Yeah. So let's talk about the factors involved. He can't quote a cost because there's not enough detail here, but the factors involved. So you have a BAS system, and when you set it up, somebody knew what the piece of equipment and the points were. And the first question would be, well, did they attempt to name them in a consistent way? Meaning they had kind of like a standard naming convention. Even though we've said, the names can't capture all of this data, one of the things that make it easier to get to the end result is if the names are consistent. But if the same thing was named 17 different ways by different people, you're going to need to understand, oh yeah, that's a supplier temperature sensor named this way, and that's a supplier temperature sensor named this way. This is the reality you face. So can you easily understand? Can a knowledgeable person easily understand what's there? Because if they can, what can be done, and is what typically done, is scripts can be written in a software application to automatically interpret and parse those names, right? And match them up against a model, right? This is a model of an air handler that's going to have these points. This is a model of an electric meter. It has these points. And these would be the tags that apply. So what we're getting to here is there is manual effort, right? And there is the opportunity for great automation of these processes. Another factor, though, will be, does the BS system you have any ability to allow for free form addition of information? Can you add components? Can you add slots? Can you add tags, right? Some systems allow that, even though they hadn't embraced a standard metadata structure. They allow you to add additional attributes and we see people go in and they can add them, and then they can get an export of the database that has this additional information. And that additional information would be in the forms of tags that describe what it is. I would say one of the biggest efforts, system integrator is going to have is just to get involved and learn, right? You're learning a new part of technology. I often make an analogy that, hey, look at over the last 20 years, the impact of IP, internet protocols, right? So now a system integrator has networking guys, who know setting up routers and how to work with IP addresses and firewalls and all of that. They weren't doing that in the 80s and 90s, most likely, but they are. They had to add that knowledge. They had to learn that, right? And this is similar. If you're going to embrace this, then you're going to need to learn about it. There's a lot of resources to learn about it. I would also say that the size of the project, whether you have, 100 points or 2,000 or 10,000, that is not linearly related to the work effort, believe it or not. Because let's think about it. If I had, 100 sites, but they were all at least named with a consistent naming convention, and there is documentation so I can understand what those names mean, even though I wasn't involved in the original project. I can set up the tables, if you will, lookup tables for a script, and I can add tags to 10,000 points as easily as 100 points if that I had that commonality, right? And even if they're not all 100% consistent, you can set up multiple lookup tables. Okay, so if the name is this way, then add these tags. Here's another alternative for that. Here's another variation of that, et cetera. So there's a lot of opportunity to programmatically solve this, but it all does really start with understanding the concepts of tagging, the different types of tags, marker tags, reference tags, et cetera, the different types of things. For example, a marker tag says, what is this? This is a sensor. But another tag you'd add is, what is it measuring, right? Air. Another tag would be, what are the units of measure, right? Might be flow, and then another sensor might pick up the temperature. And then another tag would be the relationship. What air handler is this sensor connected to, right? And another relationship might be, what schedule is this air handler related to, right? So, it's understanding these, I would call it just data modeling concepts, which are not in and of themselves that complex, but they often haven't been part of what BAS contractors have done in the past, especially if they worked in one brand of system, because, they, follow the wizards, they define the points, and they don't really understand. They've been adding semantic data. The problem is it's specific to that manufacturer. You can't get it out in a uniform way, issues like that. And I think maybe a graphic I have might help here. I'm going to show this. How can Haystack be applied under different architectures, right? So the end goal that we all want to get to, kind of like plug and play printers, right, is that end devices include the essential tags so that they can say, here's what I am, here's what my data is, here's what these different points mean, right? And manufacturers are starting to do that, but by and large, that's not the state of the industry. But if you have that, that means then your software, whether it's analytics or visualization or control or whatever, I would call that a Haystack server, that can directly consume and interpret those tags. Done. I install a Haystack compatible device. In the end, it has the tags, and boom, software applications can read it and understand exactly what the data is and take the next steps. Okay, that's an end state we all are working towards, and I think will happen because the world demands this, just like it did with printers and IT equipment. I would say the middle one we see a lot of, right? The end devices don't have tags, maybe don't even have the tagging, the capability to add any additional semantic information, right? But at some global controller level, whether you call it global controller, network controller, right? You do have the ability to add descriptive information, attributes, we're going to call them tags, right? And so you map it in there, and now you've mapped it into that network controller layer, and that means applications that can communicate with those network controllers can get the data out, and it's tagged, and it has all the meaning necessary to serve those end applications, right? In some cases, you don't have that either. So what do? Well, when you get the data, when you at the final point that you want to get the data, you add the tags there, right? But there's still value no matter where in the architecture, because once the data is tagged, it means all of the north side applications now can work with data that has meaning. So it's kind of like tag it once, use it many, many times. Great, we want to tag it as low in the architecture as possible to eliminate additional steps. But even if we have to tag it at that final step where we bring it into an analytics application, a database, a neutral database or data lake, there's tremendous value because that means all the other things I may want to do with it in the future won't have to go through that process again. They can read, consume, understand the data. It's interoperable at that point.
Yep. Just on that, I guess, not sort of mentioning different manufacturers or anything, but I mean, I suppose it does matter to some extent, like what equipment you have, where your starting point is, of course, right? Because like some manufacturers are now kind of like baking this into their platforms, aren't they? This
Yes. Yeah, we've seen numerous manufacturers who've become members of the organization and are integrating it or fully implementing it in their controllers. So there's notable names out there. Recent announcement by ALC Carrier. Of course, Tritium announced a number of years ago, building Haystack tagging into their products. So yeah, you are seeing manufacturers adopt it, right? I think, one of the things is, like most of what we've experienced in the buildings industry, new technology is adopted over time. You can say move slowly, unfortunately, because of the realities of the construction market and the built environment. But the progress is there, and the advantages are there. I've had the opportunity to see, 100 remote sites onboarded, the entire database is assembled just by, while we're sitting there watching the screen with a cup of coffee, because you can script it, right? So there's work involved, but it unleashes tremendous value and eliminates upstream work for the next thing you want to do.
And with the manufacturers adopting this, it's, adding additional value to their equipment. And so from both the deployment install perspective, the system integrator, the owner, but then also several OEMs are utilizing the data that's coming from their equipment direct themselves, and they're using Haystack to do that so that they can get a better handle on how their equipment is functioning and performing as well.
Yeah, I think that's an important point. From the point of manufacturer, they had to have some structure to their data in their device. What has been the reality of the industry is they all created their own because there weren't standards out there, right? And so there is some structure to the data in a BAS system from manufacturer A, B, C, and D. The question is, the challenges are they're not uniform. And can you even access it? Can you pull it out in a structured format? There are systems that, even though they had a structure, which is, how you were able to engineer a control system, for example, there wasn't an easy way to get that structured data out. The only thing you could get out was, here's the value of, 76.2 degrees Fahrenheit of a sensor, right? So, the people who are building products understand the need for data structures. What they're increasingly seeing is we should all work around a standard. There's no value in us inventing our own if I'm building a new product, and there's more value in us adopting a standard because it makes our systems easier to work with. The other thing I think it's coming down the pike, it's going to be a competitive disadvantage not to have a standard data markup language in your products, because that means somebody can use, manufacturer B's product more easily because you haven't adopted this. And so we're starting to see that movement with OEMs.
Yeah. I get that sort of brings me on to something else I was going to ask, because I saw in a previous slide you mentioned about it being deployed in over 30,000 facilities, which I mean is fantastic. I mean, do you have a sense of sort of how that's take up is being driven? I mean, for example, are you seeing Haystack being specified now in contracts, or is it just that it's more coming from manufacturers, or what's your sense?
Yeah, we definitely see it in specifications. Haven't been involved with Haystack since the beginning, and that's, as I say, that's my night job. My day job, of course, is with our commercial company, and I've had customers, where our software is being bid, say, well, hey, here's one of the requirements. Does your software support Haystack? And it's very rewarding to see basically that, specification being put out there. So we see it in numerous government applications, significantly adopted by the GSA and others. We see it in colleges and universities. So it is definitely reaching the specification community. And in fact, we get great evidence of that. One of the things that the organization does is publish a magazine twice a year. I think we've been doing it for about 4 years, Marc. About, six issues, another one coming out this month. And you'll see articles from consulting engineers specifically addressing the question, why do you care? Why do we care as consulting engineers? Here's why. It's been proven that it lowers the cost, it protects the owner, it creates more uniformity in how these systems are installed, because it forces people to follow a process around how they're going to name their points, how they're going to define what the data is in their system. And so, we're recommending it we're bringing it to the owners who want to build buildings, saying this is a part of the design of your project. You should absolutely be requiring Haystack tagging. And so that's a very rewarding thing. And those magazine issues are out there, and there's from numerous consulting engineers examples of them saying why it's important to them and their customers, right? And that's really, when we talk about how many buildings have have Haystack out there, right? It's really because it's solving a problem. It isn't due to the power of Marc and I getting together with you and trying to educate everybody. We can't do enough of that, right? The community's often running on its own because it solves a problem, it lowers cost, it provides value, it protects the owner, it future-proofs their system to add other applications, over time going forward. And that's our best good faith guess. Somewhere between 30, 40,000 plus facilities out there are using it, because the different manufacturers who are using it, they're doing projects every day, right? And here's another point that ties into that. That doesn't mean that the owner of the building has any knowledge of this, right? And that's another kind of interesting challenge here. This is something that's involved in the implementation of these technology systems. It doesn't mean the building owner fully knows about these things. Sophisticated owners do, people with large portfolios of buildings, and especially people who have run into the challenge of working with all the data that they've, invested in getting, right? They become believers quickly, and they impose a requirement on any vendors who are going to provide products or services to them.
Mm-hmm. I had a couple of questions come in. I think one should definitely be relevant to take now, and one perhaps sort of is about the future. So we'll take that in a bit. But this one now, could you provide a case example where the implementation of Project Haystack transformed a project?
Yeah, I would say that, we would, the best thing to do would be to look at those magazine articles. They're all submitted by people who are doing it. Ford Motor Company was in there, that they've on their automation system starting a couple of years ago said, this is the way we're doing it going forward, right? One of the key areas it helps is in the implementation of continuous monitoring based commissioning, right? If you're going to continually monitor buildings, monitor that data to provide analysis, fault detection, et cetera, you have to have uniform data coming from those buildings, right? You have to unify it at one point. But there's lots of, on the Haystack site, those magazines provide different examples from different viewpoints of different users, different engineering consultants, et cetera. So I'd have to point there to provide that type, because the applications are very diverse, right? The different value people are getting out of being able to work with their data. And I guess that's another way to look at it. The end goal is they want to work with their data, right? Haystack is just, it solves one of the challenges in getting there. So part of the question is, what value do people see in their data? What do they want to accomplish? They want to accomplish, analytics and fault detection and the energy analysis, right? And continuous monitoring-based commissioning. And Haystack gets them there because you're going to have to have a defined structure to your data, whether you're trying to perform AI or ML. In fact, I was reading an article this morning that, some studies have been done looking at AI tools that were based on, certain machine learning models, right? And they're tracking inefficiency back to the fact that the data they used to train it was not consistently marked, right? So it fed errors into the software that was trying to come up with a model, and they came up with some examples of, just changing this means you would have got a different answer out of the machine learning model. Because when it comes down to it, machine learning AI techniques, fascinating stuff, right? But it's working on data, and data has to have meaning, even for those advanced software technologies to be able to be applied.
Yeah, I guess rubbish in, rubbish out, right?
Yeah, exactly. Yeah. Another way of saying it. Although in an odd way, this article was pointing out that it was deceptively hidden errors, right? Because everybody focuses on the magic of the machine learning model, right? And these people who did this study over a couple of years were tracking back to, well, what was the data they used to train that model, and how many errors were in that original data, right? And the errors were specifically around tagging the data. And the other thing they mentioned is that they were often originally tagged with an ad hoc approach, as opposed to a very well-defined approach to how we'll tag data.
Do you guys want to move on to talk about Haystack 4?
Yeah, let's talk briefly about that. Like anything in the world of software and technology, right? The technology has advanced tremendously since we launched this in March of 2011. And I like to say to people, that, hey, does your smartphone do more than it did 10 years ago? Obviously, right? Does the Linux operating system do more than it did 10, 15 years ago? Obviously it does. And that's an interesting part of the discussion we have with people is they'll say, well, I looked at Haystack in 2013 and it didn't have A, B, and C. Yeah, this is a open source community working to understand and address these challenges and build out a standard for that. And yeah, it continues to advance. Or I looked at, and it didn't have this type of system modeled in it. Nobody had ever taken that on. And we say, well, you know a lot about that system. Why don't you come join us and help us, right? And this is, I think, something that's been a little foreign to the building automation, if you will, energy management industry. When you adopted a standard, it was like a communication standard like BACnet. There was a 250-page document, and it's all detailed there. And while it may evolve and improve, you basically implemented that document, right? This is a different challenge. This is a challenge all of society's going through, right? In addressing how do we work with data, how do we solve these challenges? So the fact that it continues to grow and continues to become more sophisticated, embrace more equipment system models, and has more sophisticated functionality to deal with what we call taxonomies and ontologies. That's a reality of where we are in solving this problem as an industry. And so, when we started out, it was called Haystack. We didn't put a number beside it, but Haystack 4 is a very important advance. It was based on collaboration effort of over 8 years of experience, people using it and coming back to the community with, hey, we need this, or I ran into this challenge, and how do I want to model this? And so Haystack 4 was introduced started working on in 2018, and it was introduced for public review. And what it did, it took the data modeling standard to the next level by defining the relationships of things like a classification tree, like how, in elementary school, you classify the different, phyla of, animals, right? Mammals and fish and birds and all that type of thing, right? And then the concept of an ontology, which is a defined way to capture the relationships between things, like energy flows. Where does the electricity go? It goes into air handlers, it goes into chillers. What's the relationship between this sensor and the systems it's connected to? And then it also included support for what's called RDF, Resource Description Framework, which is a very sophisticated software technique for defining relationships of data. And more is, a way that people want to look at the relationships between data as they're building software applications. So Haystack 4 embodied all of this in this incredibly brief touch on the subject, and then went out for public review. And in fact, this year at Haystack Connect, which we will talk about next, will be the official closure of the public review cycle, right? People have been building their commercial products off of Haystack for well over a year, because even at the initial public review, it was very solid. But again, I think a key point is this is an industry solving a challenge. It's not a light switch. There's many different systems out there. You have to bring people together to apply the methodology, the tag libraries, the ontological concepts against different systems. You get a good recent example. One of the presentations we'll have coming up at Haystack Connect, and let's shift to that topic, is from two groups out of Europe who decided to work together to define the tagging model for aquifer-based thermal energy storage systems. I've been doing HVAC systems for a long time, since the 80s, and I personally had never been involved in a project with an aquifer-based thermal energy storage system. But guess what? They're important in certain geographic areas. They're important in sections of Europe, and two organizations who on the surface might look like they were competitors, they came together because they both work on these systems, took the Haystack standards, the methodology, applied it to these sophisticated thermal energy storage systems, came back to the community, proposed the models, refined it with the input and critique of other members of the community, on how the standard was being used and how you want to characterize things, and no, you should really define your tags this way. And, do we really need a new tag for this? Or is this a use of a tag that's already defined for, different phenomena, air, gas, water, et cetera. But that shows how the community works together, which leads to this subject here, James, which is the event. In 2013, so the organization's 2 years old by that point, we took the step to create a conference and brought people together around this concept. And you can think about how new it was. One of the points I remember taking away from that 2013 event was, people saying, John, I'm not quite sure why I'm here, but I see something important happening around this data challenge, right? And what we have it's a biennial conference, all right? So it's every other year. It's coming up here May 4th through 6th. It'll be all virtual this year on a virtual platform, but it's still the community coming together. All of the content, other than a few opening remarks by Marc and I, will be delivered by the community. Here's a success story that goes to the earlier question, which will be from the Costa Group. They're a large real estate management group. I'm really interested to hear that success story. Then there's a presentation by another organization on how it's being applied in the K through 12 education market, and part of that involves it being required by specifications, right? And then, how does it get applied? How can you help it? How can it help you solve the challenges of this IoT movement and the never-ending stream of devices that are being announced that still have to be brought together. The next one's interesting, machine learning, advanced analytics techniques, they need tag data. So we're going to have a presentation for someone who's doing advanced machine learning on the key role of tagging data to support the machine learning process, right? And then, what's the next step? Interesting presentation on, which is leading to officially sanctioned conformance testing, things like that. The next one I think is great too. Somebody took the methodology and they're applying it to residential applications, right? The thermostat you buy, in the home improvement store, right? That you can connect to, but you know what? They come from different manufacturers. And while you may be able to view them all on your smartphone, they didn't organize their data and mark it up in a standard way. So this person's going to do a presentation how he brought together, I think, 4 different smart devices in his home and created a Haystack data model for them so that he could write his own applications and connect it to other applications, right? So those are some, these are the ones we call Haystack in practice. This is semi-technical. It's more talking about success stories and examples of how it's solving problems. I would say attending this and would be the best way for the person who asked that question to get, solid examples from the community on, what they went through to do it and what the benefit was, right? Then we have a much more technical track. So the State of the Union of Haystack 4 and the closure of the public review. Open source. So this is another really important part of the community is they work together, not just to define these tagging models and ontologies and improve the standards, but they build software that they release to the community in open source. There's been reference implementations for Haystack so that you could more quickly and easily build it into a new application, new product. This one's going to be very important. It's the Haystack 4 compiler, right? With all of the new Haystack 4 standard built in. That's key. A TypeScript library, again, for software developers, JSON encoding for software developers. Tritium's going to be there talking about their Haystack tag dictionary, which, that's built into Niagara now. And an interesting tie-in to digital twins, again, which are, right, digital data representations of facilities and equipment systems. Well, what do you need there? You need a uniform, standardized way of marking up your data. And so we'll have people from the digital twin side of the world talking about the tagging and how to accomplish integration across the digital twin applications and the devices and systems that are feeding data to them.
That's great. And that's actually sort of ties in with a question that was asked here in the comments about how Haystack can, what's its applicability, right, in digital twins. But I think we kind of touched on that as well, right, about this,
Yeah, well, I would say, come to the event. It's no cost, and we're recording all the presentations. So if the live event, the 3 days of, I think it's 2.5 hours a day of presentations. If you can't make the live event, you'll be able to, as long as you register, you'll get the links to all the videos and hear from people involved in digital twins. That's another thing. My role as executive director, and I've been involved in this, and I know it pretty well. But this is detailed stuff, right? And so it's really the people doing this that are the source of these, detailed answers to these technical questions, right? So come and take advantage of it. May 4th through 6th, haystackconnect.org is the link. We got numerous sponsors who are contributing their sponsorship dollars to make the event possible. That's always been a part of the event, by the way, sponsors, but people stepping up to sponsor a virtual event, which, as you know, is very different than having a trade show booth at a physical event. So we really appreciate that. We get a lot of media sponsors, including yourself for, providing this exposure, and then a number of other media organizations that serve the smart buildings, intelligent buildings, building automation, energy management industry, right?
Absolutely. No, I think
You know,
so.
and I think you can see, you know, with some of the topics that John shared with everybody that are going on at the upcoming event, that over the 10 years, just how Haystack has continually changed and adopted to the use of data and the modeling and things like that. So I think it's just, you know, by celebrating our 10 years anniversary, it just shows you that we're just keeping along, and things do change as this journey continues for everybody in the data world.
Absolutely. Just obviously a good opportunity to learn more about, there you go, haystackconnect.org. Yeah, and get involved, I guess, or at least, you know, get your learning curve of what's going on with Haystack and how you can get involved.
Yeah.
We're moving into the last sort of 10 minutes now, so I would encourage anybody to ask some questions. If you have, now's a great time, whilst you have John and Marc on the line to get your questions in. And we got two here for you guys. They're basically, I guess, the same question, right? But it's really about how and if you see a path for Haystack and Brick to merge in the future. And there was a point here again made about ASHRAE 223P.
Sure.
Could you
Yeah,
guys,
I was heavily involved in establishing that collaboration. So back in 2018, we reached out to the ASHRAE BACnet group, right? ASHRAE is, you know, predominant standard in building automation, and it has very limited, you know, semantic information that you get by default when you talk to a BACnet device. So they understood this challenge and problem. And we also talked to Brick and we said, look, we need to work together to solve this, right? Brick, you're coming at it. They came at it more from that software engineering RDF level. We came more at it from your, you know, I'm a system integrator. How am I going to effectively tag my data, right? And you have ASHRAE in the middle with the, you know, with the BACnet standard, and they're continuing to develop that. And there's a role for semantic data to be included directly in that. So we, there was a press release. We had official collaboration, and in fact, the effort of that collaboration led to the expansion of Haystack to what we now call Haystack 4. It addressed the input for RDF, for an ontology, a defined method of expressing ontologies, defining a taxonomy, extending the vocabulary into to include other tags. And we're very hopeful that the community of people involved in the built environment come together, because I guess I'd describe it this way. I've used this analogy before, but I think it's very applicable. All right, Jim, I can go to your website today and I can read everything that you've published. And I didn't have to get a software engineer to work with me to do that. And the reason for that is your website is published using a standard markup language called HTML. Early in the days of the web, it became clear that there had to be a standard way of marking up the text and pictures and whatever you want on your web page. So you have complete control of what your web page looks like, but you use HTML as the way to do the markup language so my browser can read it. And at a conceptual level, that's exactly what Haystack is about. Right? If we mark up the data with this standard approach, these tags, following these rules, then anybody can read the data and decide what they want to do with it, right? Where would we be if there were 5 different versions of HTML? Well, I can tell you where we'd be, because we actually had a short period of time we were there. Remember when you could view a website with a Netscape browser and it would look okay, but if you chose another browser, it wouldn't. And that's because the industry had not settled around and had not fully developed the HTML standard, right? The internet as we know it, the web as we know it, would not exist, and the business activities we have today and the way we conduct business would not exist if there were 5 different versions of HTML out there, right? For the good of the industry, people came together, and I know there were lots of battles and debates and arguments over the development of the HTML, and of course we moved to HTML5, which gives us our dynamic data, right? Streaming data, all of the stuff that allows us, basically, we live in a browser. We hardly ever open fat client apps anymore. Well, we believe, and it's part of our philosophy at Haystack, that the industry needs to come together and let's work together. If there's something missing, propose it. Let's hash it out. Let's add it, right? If there's libraries missing, if there was like RDF expression missing, et cetera, we need to work together on this. And that to me is the most important thing to solving this for the industry going forward. Having multiple different tagging methodologies out there will incrementally help different people, but it'll create new silos, new islands, and it'll create new work effort. Well, I've got it modeled in X and I need it in Y. Now I've got to hire a software engineer to do cross mapping, right? And in fact, you could argue that the level of the complexity of the work and the skill set required will become more difficult, because now you'll be talking about software integration between these different approaches. We believe, and we think we've seen this, that the Haystack approach of a true open source community driven effort, the flexibility and extensibility of the Haystack standard can embrace different applications, different needs, different input that we get. Again, compare it to Linux, right? It grew and features have been added over the years that didn't exist in the earlier versions, but people came together around it. Same with HTML. We believe that that's essential. That's part of our philosophy. We welcome everyone into the event. We've had ASHRAE present there. We've had attendees from other standards organizations. This is completely non-commercial. This is a group of people who've come together to solve a problem that will lift the entire industry, lower the costs of achieving intelligent, efficient, sustainable buildings for everybody. But we need to work together to solve this in one uniform way and add whatever features there are that people identify missing, just like the people who just did the Aquifer-Based thermal energy storage systems. Hey, you don't have models for those. No, I never heard of them. You know about them? Come on in and help.
Yeah, exactly. Yeah, and obviously that Connect event's going to give people the opportunity to start those conversations.
It's a good way for people to see exactly how open this is, right? Mm-hmm. I mean, just people from around the world with different areas of, JSON encoding. Somebody saw the need for that. They invested the time. They're contributing that back, right?
There's just a couple of questions that come in. Let's we're quickly running out of time. It's been it's flown by the hour, but let's just try and get these done. Two technical questions, I guess. First one, where does COBE fit into this advancement? Not something I'm familiar with, but do you guys?
Yeah, COBE and BIM don't currently fit in there, but it's been one of the outreaches we have been making and are continuing to make. In fact, we had the very first event, we had someone speaking, a keynote speaker from Autodesk talking about in the future, what you're doing here with the data coming out of devices and the BIM model that defines the facility will merge. Mm-hmm. Well, it's been, almost 10 years. There's a working group on that. We continue to try to recruit people to bring them in. What we find is one of the big challenges here is the domains are very different. BIM is and COBE, which is related there to that. These are sophisticated technologies as well. We are encouraging people to come together to create integration between those standards and Haystack. Mm-hmm. But it's up to the community, right? There's no, team on salary that's going to do this. The community's got to come together to solve it.
And I was going to suggest the person who asked that question, if you're familiar with it, come on, the door's open. Would love to have you as part of the Haystack group and get that going.
There you go. David Katz, feel free to.
Yes, David, thank you.
You got another one?
Final question here then. Does Haystack contain anything for geospatial data?
It does. That's been an area of input, I'd say, over the last 5 years, to be able to define spaces in buildings, which sometimes relate to equipment system containment and other times don't. It's actually a fairly thorny challenge, and there is that has been added into Haystack 4, and that I would say that's an area where we want people to test the models, right? Critique the models. But yes, that has been added into Haystack 4. It always included geolocation data, but geospatial, like defining, this is a space for lighting, which may be a different space for a room with a door, which may be a different space for what HVAC system serves it. So you get into some really interesting data relationship and data modeling challenges with that. But yes, the standard's been expanded to include that. We need more people to come on in and beat it up.
That's great, guys. We've run out of time. It's the hour's flown by. Yeah, and we just had a question come in, which will bring me to part of the wrap up. We have recorded this, and it will be up online on YouTube, and you will receive an email tomorrow with the link to the recording. So feel free to listen again, and please share it with colleagues. And you can share it. You can follow us on various social media, Twitter, for example, and I'll put a link to it there as well. So really, just to say, great. Look, thanks, John. Thanks, Marc. Great stuff, and I'm looking forward to the Haystack Connect event. I'm sure it's going to be great. And again, every people who've listened, this is a really good opportunity to contribute to this effort.
Well, thanks again for your
you.
help in us sharing the information and getting this out to the community so that they can join us, evaluate it, work together with us.
Good. And then final question. Yes, there will be a link to download the slides rather than the video. That will be on our website. Look on the website tomorrow. We'll put the slides up there. Great. Thanks, guys.
All right. Thanks so much.
Thank you.
Bye-bye.
Thanks, John.